Welcome to Java 1. This is the Java JVM Performance BOF. And we have a few panelists here that we're going to introduce.
All right, I guess I'll start off. I'm David Keenan. I am the Java Platform Performance Architect. Been working with performance for more than a decade. Did my math right. But yeah, so this is just an open forum for answers, to answer your questions, and so be looking forward to it.
My name is Michael Vidstead. I'm working as JVM architect with the HotSpot and to some extent, I guess, the JRocket JVM. Have been working with JVMs for 12-something years now.
I'm Monica Beckwith, and I'm a Java performance engineer. More recently, I'm working with G1, GC, as well as garbage collectors in general.
And the panelists also have other sessions here at Java 1. My name is Jerry Driscoll. I'm with Oracle. I've been with Sun for 20 years prior to Oracle. I'm currently the director of Java Performance. Next slide. So this is the typical disclaimer that we can only say things that we're supposed to say. And why we are here. So basically what Dave just said is the reason why we're here is to field questions on anything about Java performance. I mean, we have the panel here who is very intelligent, knowledgeable about the JVM, but we also do performance work throughout the platform stack. And they are very knowledgeable about not only the JVM, but core libraries and other performance components within the platform. So with that, what we would like to do is to open up the room to questions. If you would raise your hand and ask your question, we might have you either come to the mic up front here to ask your question so it can be heard by the whole audience, and that way we won't have to repeat questions.
Yeah, it's too bad we don't have the mics in the middle of the room like we used to have, right? So, as you ask the questions, we'll try to repeat them. If you're comfortable coming up, please do so, because you framing your own question is always better than me trying to repeat it. So, first hand right here. Right here.
Okay, my first question will be about boxed types, list of integers, etc., etc. Since 1.5, we solved this in a language, but haven't solved performance problems yet. So there are multiple solution detect pointers or specializing collections for different types. I mean, is there anything going to that direction?
So funnily enough, with the dynamic languages and with the Invoke Dynamic 292 implementation, we've realized that, or we've seen that in many cases, the new languages and to some extent, obviously Java as well, method handlers and all of these are using boxed primitives for sure in many cases. And the work we're actually, starting to work on now hard after. So what we did was to basically rewrite parts of the 292 Invoke Dynamic implementation over the last year or so. And in the next step now with that work done, we're moving over towards doing more optimizations like the one you're talking about, boxing elimination. There is also, it's combined with inlining to a large extent as well. So we are working on it. We will improve it over the next few months. And yeah.
Can you apply directions, like are going to be tagging types, tagging pointers, stuff like that? Like what specific things you will be doing?
Right. So short term, it's mostly around making sure that the boxing elimination we kind of have today is more generically applicable. And long term, we also have. So if you were if you attended the JVM Language Summit, John Rose had a presentation on what he calls Arrays 2.0, which is essentially trying to take data representation in Java to the next level. It's not only about making arrays larger, it's around making the representation more flexible and providing better data locality and layout, allowing you to express data in new ways. And as part of that, also looking at value types, so being able to dynamically change, I guess, the nature of data during runtime, which is I'm hoping what the question you had basically.
Were you aware of what we have now for out-of-box elision, or?
Yeah, I know what you have now, but it's limited to, I believe, in lining. So
Oh yeah, pattern
yeah,
match.
but my question was about the data structures that are memory listed maps.
Right. For some of you probably heard us announce the product Sumatra very recently. Sumatra is trying to leverage GPUs and enable offloading of data parallelized workloads to the GPU. As part of that, it's very natural. There's a clear overlap with the whole data representation problem. GPUs tend to want to have data represented in another way, and obviously to enable the bridging between Java and GPUs, that's clearly an area we need to invest in. So short term, it's around improving the optimizations we have, but more long term, it's completely revamping, I guess, the data representation and making it more flexible.
Hi. So at present, HotSpot doesn't have particularly good ways to see a lot of detail about what's being done at compilation time. So JIT compilation time, obviously, rather than JAVAC. So other JVMs have the ability to dump code by default at runtime. With HotSpot, that's not possible in a product build, only with a fast debug build. So what's the story about getting actually more information out of the product builds?
Can you expand that to just general serviceability of the cache, code cache?
Yes, being able to see more of what's in the code cache and actually the dynamics of how that works would be very helpful.
Right. So we have actually work going on in this area, and part of it is being able to control the compiler in a better way. So if if you're trying to support the JVM, for example, as we do, it helps to be able to reproduce different kinds of optimizations in exactly the way that the JVM did them. So there's a JET for this that was published 2 days ago or something, called Compiler Control and Logging, I think.
Do you have a number for it?
I do not have the number in my head. It's on openjdk.java.net/jeps in the long list. And so that product consists of 2 different parts. One is enabling users to control what's actually going on and which optimizations to apply. But the other part is also to visualize and improve the logging, I guess, of what's actually going on.
So I'm curious, what type of information specifically are you looking for? Like types of optimizations?
Well, I mean, to start with, just dumping the assembly that's actually being produced.
Okay.
Currently, that's like that. You need an HDIS plugin for all of that, and that's.
Yeah, that's print out too, right?
I think there's a bigger issue too, is that we sometimes need to know what's being compiled and what's not being compiled. And currently, the only way to do it is really with a print compilation. It's fairly inadequate.
Yes, right. Print compilation is several orders of magnitude too little information.
Now, there are several profilers that give you this level of information as far as what the generated code is, and it doesn't step through the decisions that we made as far as optimizations, and we're considering such things. Are you aware of those, like the Studio Analyzer, VTune, things like that?
Yes, but there are significant problems with using VTune against the JVM.
Agreed. So try Studio Analyzer.
Studio Analyzer is Solaris.
And then Linux.
And Linux too.
And Linux.
Oh, is it on Linux now?
Yeah, and
It's
yes.
been on Linux, yeah, for a while.
Yeah, it's been Linux. It's actually working quite well on Linux at this
Yeah.
point. Yeah, it was on Linux for quite some time, and I wouldn't suggest it until last year or so. So, yeah.
Okay, cool. Thank you.
Okay, but if we need to hook in our own tooling, then we still need some sort of access.
No, agreed. I mean, well heard. We understand. Yeah, absolutely. I think that's certainly would be valuable. And as far as we have our own internal requirements along those lines as well. So, yeah. Okay, we got one over here. And guys, I mean, I was happy. I very much appreciate you coming up, but if you want to yell them out, that's okay too.
Okay, so regarding this. This question, in particular, the last one, is there any way to actually know when the compiler decides to not do any optimization, that would be also interesting. Like why it's not inlining things or not optimizing things because, for example, methods too long or too many loops, whatever.
So, I mean, in situations where we choose specifically, like the counter's tripped and we were going to compile and we chose not to, that information, for the most part, I mean, there's some of that information available now in print compilation. And, I mean, using the fast debug builds, you get more.
Yeah.
I would have to ask Michael if there's more that I'm not aware of.
Right. I mean, the obvious problem is there's a number of optimizations we apply. In some cases, there are reasons for them not, triggering on that specific part of the code, and clearly it's hard to know what it is that isn't happening. It's easier to describe what's happening than what's not happening, clearly. So it's a challenge, but I think, it sounds like an area where many people are, having problems or want to see improvements. I'm hoping that, again, the compiler control and logging project can help, at least take the first step towards simplifying that.
Right. So the information that is available is that if you were eligible to compile and we chose not to, there is a certain amount of information. It's not incredibly detailed, but it gives you some idea. Method too large, code cache full, things like that.
Yeah, and related to this as well, do you have any tips that one can implement in actual code to actually make it more JIT friendly? Like, for example, not doing switch because switches are not easily optimized, or if you can it's better to, I don't know, for example, if you have a very hot piece of code, maybe just dump everything to a single class, because if it's multiple class, then it becomes a megamorphic call and it's not optimized and stuff like that.
Our general suggestion with this type of level of optimization is to generate, write clean, human readable, easy, simple code.
Yeah, but a switch can be human readable.
I know, I understand that, but you're only achieving the last 5% of optimization at best by doing hand tuning along those lines. And you might trip over what we're trying to optimize in your next release. So, in the past, absolutely, I would say that there were opportunities in which you can manipulate your code in a fashion that would yield significant performance improvements. Those opportunities are less, and it's to the point now where you may be impeding your future performance by doing such things. So, if you see a situation saying that hey, if I put it all in as one big class and, there's a megamorphic, it's not megamorphic and you're seeing a big performance benefit, then tell us, because most likely we can fix it rather quickly, in those situations. So that's general guidelines. I understand, I live in a world where I'm optimizing the snot out of things, right? So that's different. It's easy for me to say that to you. So I understand if that problem. But in the general sense, we want to, we don't want to, the better the code you can hand us, the better optimized we're going to be.
Can I abuse for the last one?
Sure.
You said before that the JSR 292 rewrite has been landed somewhere. Is there any plan to replace the JDK 7 one or backport it to JDK 7? Do you have any estimate for the U version that will happen?
So the goal is to have it go into 7 as well, yes. And the current plan is to have it go into 7U12, if I'm not mistaken.
Thanks.
So my question's about autoboxing again. So bring back and escape analysis, because I did some tests in Java 6 and I found that if you write a method where you're constructing new integer objects all the time, it was about 8 times faster than using autoboxing because of escape analysis, which doesn't kick in. In Java 7, it's about 25 times faster. And so making a new integer, which looks like it would be slower, is actually fast, and in Java 7 that actually is about the same speed as just using primitives for the same calculation. So and it's one of the reasons I believe is because of the integer cache inside integer. Now, is there any possibility of getting rid of that integer cache?
No, so the integer cache is there specifically to aid our previous implementation of autobox elision for that code path specifically. I mean, it's one of the hottest, new ints, take a look at your class profile, you'll see that chances are there's an awful lot of them. So that's why we specifically chose that. And our previous autobox elision implementation was really a pattern match. more or less. We had several patterns that we knew we wanted to go after, and that's what we went after, and one of them is right there. So as I won't be specific in this answer, but as we enhance our escape analysis, as we enhance our autobox elision, those structures that we had that we may find to be an impedance of the new implementation will most certainly be removed. Yes. So if that's, and I think that type of situation, when we're concerned about footprint, and I think that's a pretty ripe optimization to get rid of that extra large array. Right?
So to that, in Java 7, you've got an assertion inside the value of method, which increases the size to beyond 35 byte clicks.
Right.
Right.
So, yeah, so exactly. So on the topic of limiting optimization based on bytecodes, that's one of the things we're looking into right now, to revisit and update and in many cases hopefully remove completely these fairly artificial limits on inlining on different kinds of optimizations. In many cases, they're not even based on live data, if you so will, in the compiler. So we have nodes internally. We're in some cases basing the limits on the total number of nodes we've ever had. It's not necessarily a fact that they're still there. So I think in many cases we're going to relax and improve things like that, and hopefully a few of the artificial limitations you now have to work around will no longer be a problem.
Yeah, go ahead. We'll come back to you first.
Just general question, where do we send feedback on performance? Like if we see some piece of code that does not, look at estimates, should have been optimized much better, where do we send it?
So this is a question I've gotten a few times now, and we will make steps to get an open JDK performance alias. It's not there now. So if you can take the step of determining which subcomponent is your problem and talk to that alias, that'd be fantastic, but we will have a performance alias.
So meanwhile, what's your phone number?
Monica, I'm sorry. Let me look it up quick now. Sorry.
So just a general comment, which is kind of a follow-up to that one. When people are submitting MicroBenchmarks and things, can they please submit a URL which has a complete link to their entire test harness? The number of times that we have to deal with people that claim they found a regression or a thing in a benchmark and you look at the test harness.
So right. Along those lines, that I shouldn't overstep. I'm going to do it anyway. We have MicroBenchmark suites that we would like to get into the open, and we are doing the best we can to get that there as quick as possible. So we hope that is effective and helpful. But there's bringing things to open source is not a small and short process if it involves lawyers. Right?
So actually, I'd like to move to locks.
Sure.
Possible? Should I come in here?
Yeah, go right ahead.
So what I've noticed in the field is that about the vast majority of locks that you see actually used in applications, if you look at thousands and thousands of thread dumps, which unfortunately I've had to do, that you notice that the vast majority of them are just absolutely could be deleted away almost immediately, or the vast majority of them at least could be biased almost immediately without actually doing any analysis. And it looks like it'd be much better to actually bias do a greedy biasing up front, and then do an unbiased later if need be.
Yeah, that is our.
I don't know if you've done any statistical studies or anything like on this, but that's the option.
Bias locking is on by default.
Right. But you have a delay applied.
There is a delay applied, and that's because there was.
You still have to do the analysis before you apply it, right? So.
No, there's a delay because of startup impact.
Right.
That's what we're most concerned about there, is that during the startup, the phase of startup, there are indeed a lot of revocations that we would have to happen. So we delay the effect of bias locking until we know that we're past that phase, that we know we'd have a set that we'd need to revoke. That's essentially it. Revocation is expensive. We do an epic-based set revocation scheme, which has helped quite a bit. However, so that's a heuristic adjustment. That's good feedback. So I might want, bias locking is kind of, As you get into newer CPUs, as they come out, the cost of that uncontended lock is less and less. We've actually found situations now where bias locking, because the potential of having a replication, bias locking is actually an impedance to some workloads. So we have to make that decision. Is bias locking something we want to keep? Is bias locking something that we want to adjust the heuristics? And perhaps the feedback that you have here, Kirk, is something that we want to hear more about. So we've had that same observation. The large majority of locks and synchronization events are indeed uncontended. There's bias locking, and then there's extending escape analysis.
It's not only that they're uncontended, there's just absolutely no possible way that they could.
Well, right. So enhancing our escape analysis will help us there as well, because we have a flow-sensitive implementation now that limits our scope greatly.
Right. Yeah.
Going to flow insensitive in Java is daunting,
Yes.
right? So we're working on that as best as we can. But yeah, we have two avenues approach. I think long-term, if done right, escape analysis has a lot of benefit in that situation. And that's really the best way to do it. Just get rid of the lock if we know we don't need to use it, right? Having heuristics around how we handle the lock is with any heuristic, there's a pitfall. And sometimes those cliffs can be rather significant.
Yeah,
So.
sure.
Did you have more to add, Michael?
Not a whole lot. No.
Okay.
We're looking both at uncontended locking and removing those, but also contended locking. So we're continuously improving the locking implementation, and it's good feedback for sure.
Yeah, actually, the contended locking improvements, are they back in JDK at this point, or?
So that's so it's work we're picking up from Oracle Labs. It's slowly making itself into the code base, so you'll see changes there.
Yeah, Dave Dice, the same engineer that's been working on our contended locking schemes for the longest time, is still continues to do that from the lab. So thank God.
Right.
It's just nice to get the data from real apps.
Oh yeah, agreed. Okay, so I'm gonna. This gentleman in the back had his hand up for a while, so.
Thank you. Is it possible technically to change JVM parameters that affect garbage collector behavior during the runtime?
Okay, so the question is, can we change garbage collection tuning parameters during runtime within the same collector framework? Is that supported? You know this better than I do.
Well, so can you give examples of parameters that you would like to change?
Like heap sizing, for instance.
Well, I looked at the value parameters. There are about 10 of them. I mean, the size of the old generation, the size of the old population, generation, and the permanent, right? And then the time, what is considered to be old and young generation, and things like that. I don't know all of them, but I have a session tomorrow actually, and I heard that there is idea to create adaptive self-optimizing virtual machine for JDK 8. And the idea is to use some kind of machine learning or something and to sample the data of a running application on a specific hardware and then to learn from that and to adjust the parameters. So I'm interested, is it possible to track that and during the runtime to adjust the parameters, or it requires the restart of the virtual machine?
Right, so I think, so basically, first of all, I want to say that the permgen is gone. In JDK 8, you will no longer have to specify permgen sizing
there
options.
There are no limitations at that point.
Permgen problems are not gone.
No.
They're not gone, that's right. We've shifted them.
But the maximum size problem
And
is
they're
alleviated.
actually worse because you've moved some of that into native code, so we have no tooling to actually sort out the problems that we normally put it sorted out.
So I think that's both the yes and no. I think we've obviously moved some of the data, and obviously we need to look at it. This is again a good feedback. We realize that things have moved around, and in some cases we need to provide tooling to support finding the new issues or figuring out where memory goes. As part of that, we've also done the native memory tracking feature, which is tracking memory on the native side. So some of the tooling already exists, but I'm sure we'll find more cases, more primitives or tools that you will want to find things.
Yeah, but the reality is that the permgen was in a large majority of applications, not the ones that we're trying to tune heavily, but in a large majority of applications was just simply wasted space. So having this separate region where there was a fixed size where a large majority of the time we just simply were using the size. In this environment where we want to cram as many JVMs into your cloud box in the sky, that's something that we just don't want to do anymore, right? So there you go.
Yeah.
Sorry.
Exactly. So moving over to the more general case, I guess. I think what is hard is to completely change the garbage collector framework, for example, going from CMS to serial all of a sudden. That's a very big impact, and But what our strategy on the GC side very specifically is to use G1 as the framework of choice going forward. And some of the tuning you're mentioning, all those 10 or 20 or 100 flags that you have to specify today, our goal is to make sure that you don't have to specify them even to start with. That the G1 collector actually tunes itself using heuristics. And obviously, realistically, as I think I mentioned in my earlier session today, there will always be cases where you can squeeze out a few more % by manually tuning things. But our goal is to make sure that for the common case, 95%, whatever, even more than that, you shouldn't have to specify these parameters.
Right. So, but to be very specific, so I'd say the answer is yes and no. So, I mean, Michael was talking to do with the difference in the framework. So, shifting from CMS to parallel GC, no, you can't make that change. Shifting from any of the frameworks to each other, that's not supported. If you have your defaults as far as the maximum heap size and the minimum heap size, and the same thing for the young generation, yes, you can manipulate those on the fly, using tools. Thread counts, things like that. Some. So it's a yes and no question. But as to Michael's point. Once our fruition with G1 happens, not only should you not have to do it, but most likely, you can change what you want because it'll be one unified framework. Yeah. Okay, gentleman right here. Sorry.
So two things I put a lot in my code are assert statements and finally keywords, both on local variables and class member variables. Do either of those have any impact on performance in production where asserts are turned off?
No. No impact.
No impact at all. I can put asserts all over the place.
Right, and the only, again, if they're turned off, the only exception to that would be, again, the artificial limits on inlining sizes and things like that, which...
with us for another year or so.
Right.
Sure. But again, it's like, yeah. So in some cases, you will run into those weird bastard cases where one more bytecode will actually make a difference. Yeah. We're working hard on making sure that that's not the case. So hold your breath.
No optimizations that you can do to parallelize, I don't know, a long method if you know something's final that
yes.
You wouldn't otherwise?
Not really, no. In the normal case...
Sorry, I said
what was that?
earlier.
Final's not final.
Final's not final.
It's effectively final.
Final's not final. So
that's right.
I can't use it as an assumption.
Yeah, we can make certain levels of assumption, and we can make, but that is, from an application code level, there's no.
And Kirk is absolutely right. Final isn't final. So,
in Java,
so
unfortunately,
so to speak.
We have a couple questions on the other side of the room.
Oh, good.
Hi, I'm running Diagnostics. My question is about the surprises in performance tuning. I recently came to a very curious case where I came up with a set of parameters, supposed to be very good, add in memory, use large pages, and use CMS, but the performance was horrible, 30% worse. I checked into the final flags. I noticed that some flags that did not specify got changed. And once I compared those, I reset those to previous levels, the performance improved. So how do I handle this surprising change?
So when you change those parameters back, did you see the level of performance you were expecting?
Yes.
Well, that's a bug.
I think he changed the collector, is what he's saying. He changed
He changed the large pages.
So there is a so in JDK, there is a bug surrounding that.
I noticed that some parameters which sound very important, like click inlining and P-lab sizes, those got changed without my specifying.
So this is use NUMA that you specified? Is that what you said? I'm sorry? Or it was large pages?
Large pages?
Yeah, that's on Red Hat. Linux?
Yeah.
Yeah, there was a bug in JDK 6 surrounding that. So that the workaround is to disable large pages. Yeah, we ran into that. Or go to, what's the update, Charlie? 33 or Update 33 of 34 has it fixed, thanks to our friends at Salesforce.
You guys did that deliberately, right?
Yes.
Yes, yeah, that's the goal.
If runnings, no.
Another question?
There's one more over there.
Yeah, kind of a high-level general question. So there's some well-known patterns that indicate there is a performance problem. Frequent context switches with threads because you have too many threads trying to run concurrently, and especially with loads that change very frequently. Has there been any consideration to build into the VM any kind of JVM event to notify you, say, hey, things are going really bad and maybe you should take a look, or just make it up to the tools that you do?
Like a self-diagnostic VM?
Yeah, and I'm not sure it needs maybe to be in the JVM itself, but it clearly would help to have tools that could help you find these kinds of problems, right? Yeah.
I think Kurt's got some idea.
Right. So in many cases, if you look at it, what we're trying to do in the JVM is not necessarily solve the whole problem, but expose suitable primitives so that other people can take that to the next level by building tools on top of it. And context switches is maybe one example of a primitive that we could choose to expose if we don't already do it today. I'm not sure if we have the OS beans and things like that exposing that. Well,
You don't have much.
right. Okay. And then have again tools vendors help developers optimize code based on that. Right. I don't know. Not sure if that answered the question, but that's my best.
And we had some
take on it.
dtrace scripts that did something similar.
That's right.
This one over here.
Okay, well, you're next. Go. Let me get this guy first, and then you can go.
Sure. So I'm in Java 6 using the CMS collector, and I've allocated a lot of memory that doesn't change ever for the lifetime of my program. I've noticed that seems to make garbage collection, the incremental ones, have to take longer. Should that be possible, or should that be impossible?
That should be possible.
No, the general sense is that you're going to spend more data, and the more live data you have, the more time you spend in garbage collection.
Even the incremental pauses, like the small ones, not the stuff of the world.
You mean so you're talking the concurrent phases in CMS? Is that?
Yeah.
And it's increasing over time? Is that what you're saying?
Just run A versus run B. Run B has a large amount of static, very old, surely tenured data.
Yeah, of course.
Yeah.
Absolutely.
You got to go through the live data. I mean, and the more live data you have, the more time you're going to spend. Unless you're running G1, right?
Q1. We have a talk.
So G1 actually. So the idea of G1, and there's two talks that are coming up. We have an advanced tuning talk tomorrow at 10 in this room, and then there's the G1 tuning talk, which will give you more information than you can possibly imagine about G1. And I'm sure that will be addressed there as well. So, but that particular problem, increasing live data set, CMS in particular with a concurrent garbage collector, not only, so there's two problems to try to address with G1. That situation, very huge heaps, we want to be able to guarantee the low latencies, but also as you get into that situation, eventually you're going to have fragmentation. And eventually you're going to have to, so how do you handle the fragmentation? CMS is not going to handle the fragmentation. So that's why we have G1 now.
Fragmentation is a time water.
Yeah.
So all you have to do is configure a heap so that you win and it loses.
Yeah, in your time, exactly.
We should use that.
It's the race, right?
It's a time race, so you can deal with it. You just have to go into some really interesting heap configurations. We can talk about it later. But
Given time, yeah.
Yeah, if you give it enough time, it'll work itself out.
Okay. Go ahead.
Yeah, with all the new I/O stuff, are you paying attention to performance of byte buffers? Because I believe there's still slightly different performance from byte arrays.
So yes, those paths are highly and heavily used in a lot of enterprise applications. So in general, absolutely.
Build the range check combination is not working as good on byte buffers than on byte arrays.
Okay. All right. So I guess in an effort to improve things in general, if you have a micro workload that shows that easily, we would love to see that. Yes. We have a gentleman over here that's been had his hand up for a while. If you don't mind, go right ahead.
So this is crazy, but what sort of performance would you see if you had to go and re-implement invoke into some sort of invoke dynamic?
What was that?
Is John Rose around?
So repeat that one more time. So re-implementing the invoke interface on top of invoke dynamic is what you said. Right? It's right. That sounds very interesting. I don't know what the G. I mean, it sounds.
It's almost like we're doing the opposite today. We're kind of implementing invoke dynamic on top of invoke interface, I guess. I have to admit failure here, and
So that's. I have to. I'm curious where the question came from. So as if you want to let us know on the aliases, and we can certainly try to dig a little deeper. But we don't know.
Or just share whatever it is that you've been smoking.
But if you have numbers, if you see the differences. I mean, obviously you're not going to see it, but maybe if you have ideas surrounding this, then we'd be certainly willing to discuss it. It's tough to. No, I just don't. Got you on the open forum, right?
Yeah.
That's right. Okay, so gentleman in the back.
Yeah, is there any chance to see multi-tenancy support at the JVM level in the future? Well, especially after Jigsaw, of course. I mean,
yes.
What are the plans for it, and how do you go about doing that?
So to some extent, so this is an area where, we're ramping up the effort in right now. It's not as if we don't have anything in this space already. So we have class data sharing today already in the HotSpot VM. It was, before the PermGen removal project, it was limited to the serial collector, but one of the nice fallouts of the PermGen removal project was that it now actually kind of works on all the collectors trivially, automatically. The whole, dynamic environment that clouds come with and all that is clearly something where the JVM is in a unique position to help. Again, we are already virtualizing things for the application. We plan to continue doing that. And clearly, if we want to adapt to the environment we're running in, to size things up and down, and I've forgotten what the question you had actually was. Sorry.
Work with application servers in a level of IO resources, CPU, and memory.
Right.
So applications inside an application server on top of JVM can deal with that. Because multi-tenancy, we have two scopes of things. We have data multi-tenancy in the database, and we have resources at JVM. So database is easy to solve, but what about the JVM?
So basically, I think there's the interesting trade-off here is between sharing of memory and isolation. So the more you share, the less isolation you'll have. The more isolation you want, the less you'll be able to share. And it's not only on the data side of things, it's on any kind of resource. So if you think about it, it's everything from network I/O to CPU utilization to whatever. If you had an infinite amount of time, I think you could start in either end and you'll end up in the middle. You'll have basically the same thing in there somewhere where you're sharing the maximal amount of memory possible while still having some kind of isolation in there. So the interesting part is really from which end do you approach this? Class data sharing to some extent starts in the end where everything is isolated first. You only share what is reasonable to share. And in this case, it's the class metadata. You share it transparently using the OS level functionality to do that. You can also approach it from the very other end. So one of the projects that Oracle Labs again have been working on for many years is the MVM project, implementing the isolates JSR. I forget the number. Which is starting in kind of the other end, where you're sharing everything to start with, and then you're figuring out what to not share. And again, the trade-off there is a complex one. In many cases, it's okay to sacrifice some isolation in order to gain more shareability. In the other cases, you really want that secure isolation, so it all depends on what your end goal is. we have solutions in both spaces, and we're constantly improving these as well. And we're still, working on both ends of the spectrum or the scale.
We get one guy over here, and then we'll get you next. Go right ahead.
Just a general question. I mean, there's a lot of JVM flags. Somebody was saying that funded for the collectors, but the documentation on them are in most cases like this is this. What is that? I mean, there's no answer. And also if you look at the print final flags, you see that what's the default values for this or in the documentation. But I'm not sure if in some cases the logic behind that default, why this is this in this platform and that in that platform, or why this is 16 not 32, that can probably in some cases help us decide which parameters to choose.
So you can talk about it.
Look at the source.
Should I say something? One of the things I can say is that we are aware of the fact that the documentation around our command line parameters there's room for improvement. And so one of the projects that is currently ongoing is to clean that up and to be more clear around what parameters we expect people to actually change, and to make sure that those are both documented and tested and supported and the works. The ones we're not documenting are command line options we're hoping that people either won't have to use to start with, or are so esoteric that it doesn't really make sense to document them. So that's the first step, I would say, just cleaning up what we have there today. On top of that, and we like to come back to this, is G1, where hopefully we can reduce the number of parameters you have to specify to start with. And then there's clearly, as you point out, in some cases it says 16 in there, and it's not exactly clear why. And I think in many cases it isn't clear exactly why that is 16 and what drove that decision. The code base is 15 years old. I'm sure people made experiments and wrote 16 in there for a reason. That may have changed since, and I think that's.
But a lot of these flags.
If it's just on empirical evidence of something, that's one thing. And in some cases, if it's depending on some of the application behavior, ideally this sort of application helps with this sort of behavior, then you know that my application doesn't fit in that profile, or my OS configuration doesn't fit in that profile. In that case, I will change it. But if it fits on that profile, I shouldn't change it. So that's the reason I'm asking the explanation behind. If there is an explanation behind that,
I think you just hit the last point. If there is actually an explanation behind it, we will certainly get that explanation in this next wave of fixing things. But we just weren't, to be honest with you, we created flags for debugging our development, and weren't very careful about what was left open and left out there. So now you have more flags than you could possibly imagine, and a lot of them don't really do anything.
Is this where I say that there are 500 in product?
There's a lot, and we regret that situation, and we're trying to fix that. I mean, we went open source without fixing that problem, and we probably should have not done that. So, to be very frank, but.
And internally, I have the same problem too. So what I do is I look at the source and try to figure it out myself if I don't find any engineers that can help me. So I have similar issues. So.
But we can't. I mean, it should be documented if it means something.
And for G1, we're trying, through blogs and stuff like that. People are we're trying to get more information out there, especially the phases of G1 and just understanding the G1 logs and stuff like that.
As part of the JVM or the flags is that some of these features changes and you get a blog that for the last 6 months is not really up to date, and the meaning or the behavior of the behavior has changed. So
that's right. But these are engineers who are writing the blogs too. So you'd rather have them working on the product than update the blog every day, right?
Yeah.
Right. No, but I mean, referring to the source code, crude as it may be, in some case is the only way to get there. I mean, a garbage collector, for example, is a really complex thing. So in many cases, it's really hard to describe it. It's really hard to predict how people are going to use it and how the applications behave. So we're trying to provide sane defaults for our flags. In some cases, I'm sure we chose approximately the right numbers. In some cases, we didn't. It's a really hard problem. I mean, we could remove all the parameters as well, but that would clearly, make it harder in many cases to tune the product. Some people would probably be happier because there are less things. It's like my iPhone. I know that it can do some things well, and those things it does really well. Other things it can't do, and I know there's no way I'm going to get it to do that. So
it is what it is.
It is what it is. Exactly.
Okay, we've got maybe 2 questions. Okay, go right ahead.
So I'd like to go back to G1, and please take it well.
Oh yeah, sure.
My experience with G1 so far, I've been using it since it was an experimental collector, is that it's still a little bit behind, especially in stop-the-world performance with respect to CMS, and especially compared to the deterministic collector of JRocket. So I wanted to know if you have a plan where you can say G1 performance, arrived on par with CMS, and that's from there on you can actually say, okay, this is the collector of the future, because I understand it's the replacement, the long-term replacement for CMS, but I feel it's not there yet.
No, it isn't there yet. No. Yeah, okay, it's only there in limited cases, and I'll just take it.
Yeah, the plan. They can tell you, but I'm working on it every day. So yes, we're trying to get there, and I would like to know your specific case, and I would like to help you. Yeah, sure.
Okay. Yeah. We exchanged a couple of emails about.
Oh, what's your name?
Yeah. Right. Take it offline.
No, but I think this is really, if you have problems with G1, or if you have an application that you would like to, for us to focus on, this is really your chance. Like G1, we understand that it's a new collector, and that means that, the range of applications that G1 performs well on is fairly limited right now. Our goal is to widen that, as quickly as possible, but we really need your feedback to help drive that work. So please work with Monica and the performance team to provide feedback on where G1 isn't really performing as well.
The defaults for G1 as it stands now, depending on your application behavior, it may not match it, and it may perform quite poorly.
And the defaults were there for a reason, and I ran the test to say that 20% and 80% for nursery is what we want to begin with, because we have to start somewhere, right? And then try to get most of the applications. Now, depending on your heap size, we'll talk about this in the G1 talk and a little bit tomorrow as well. But sure, I'd like to know your application.
Okay. And is there any plan to port the deterministic collector of JRocket into G1, or as an alternative algorithm, collection algorithm available?
There's no plan to port deterministic GC specifically from JRocket to HotSpot, but we do have, in the pipe work to implement low latency or pauseless GCs in HotSpot. Again, on top of the G1 framework.
Right. So
open source or for pay?
That is a product management decision that I happily hand over to product management. Yeah. We're going over now.
Okay.
All right, so we're done. Thank you very much.
Thank you.
Hey, good job, Michael.